So that's normal deficiency, but I can't figure out how to scan that. I think the second stage of that.
I think we need to give people a couple minutes to get lost. We've got extra time on the agenda.
Yeah, there they are. Chris.
I'm Chris.
Yeah,
All right.
Yes.
Chris, you want to come look and make sure I got the right version of your slides? How will you know?
Good second slide. Yep.
Okay.
Thanks.
I kind of feel like I but they still put. Yeah. I have extensive OPS for well, and they also they know your name, and they also send it to my IETF. So they don't actually know your name. They don't actually know my name. I must be itched. One of those weird names.
You guys also have pens, not pen on the blue sheet.
Oh, yeah, I think so. Yeah.
Thanks, Tom.
My mom, I knew your body is married.
Yeah, we have. So we rehearsed something. But we didn't need
So we are still missing our primary note taker, so Aaron went out to fetch him. So we're giving people a couple of more minutes to come in, join us. Yeah. So we're 2 minutes over. What do you think? Have you found your note taker?
I know. We have some explaining to do. I actually thought of it, before the meeting started. Made arrangements, and then he didn't show it.
Okay.
I think he'll be here.
Aaron, you're on night shift.
Oh, am I?
Yeah.
I thought it's supposed to automatically undo night shift when you.
What time zone are you in?
That's an excellent question.
I was blaming the screen.
No, well, it's oh, my menu bar has gotten all wonky. Yes, just in time to present. Night shift.
So
No.
Oh, that's interesting.
Are you ready? You're ready now. You just have one there for like a month.
Oh, it's not just night shift, it's flux.
Yes. Oh, you were pausing by the weekend. What? No.
So
no, I just pulled it up. I was like,
yeah, no, it's
There, now let's see where.
now it's super bright. So what should we do? Shall we welcome everybody and say like?
Sure, we have a note taker. We'll see if the next one gets here. Let's just. Maybe you can do the thing. Blue sheets.
It's already back here.
Hmm?
It's already back here.
Yeah, but new people are coming in.
Yeah.
Oh, they stole the pen.
One blue sheet has.
Has anybody
both
not
of
signed the blue
pens.
sheets? Who's not signed the blue sheets? Raise your hand.
Okay.
Okay.
A lot of
Look that way, Chris. Those people need the
Chris, I think there is a.
Who stole the pen? All right. So Dave stole the clipboards and you stole the pen. We have a lot of thieves in this group.
No, I gave the other blue sheet.
Both clipboards, each clipboard had a pen when they were left here. That's all I'm saying. All right, let's go.
shall we start then? Just
Yeah.
5 minutes over?
Yeah.
Good morning and welcome to this TAPS session at IETF 101. For those who are new to this working group, I mean, this working group is working on an abstract API where application doesn't tell which transport to use, rather get the transport as a services by telling them what they want to do. So this is not well. I think most of us know about it. If you're not, please have a look and also read about the web pages. So this is me, Jahidur Jamal Sharkar. I'm co-chairing this TAPS working group with Arun Falk. Hello, Arun. So I think it will be a 2.5 hour long session, and we're hoping and very exciting and involved discussions and presentations. Arun? Oh. So this is the agenda, how the agenda look like. Anybody want to change anything? Yeah? Yeah, sure.
In the interest of time, to leave more room for the TAP stuff that's going to happen with the big three drafts, I'm probably going to cut my talk down just slightly. Just take it into account.
Yeah, that's fine. It's up to you. Just need to hurry up.
Since you're up at the front,
Yeah.
it's easy. We don't have to reschedule anything. Everything will just move up.
Yeah.
Also, technically, number 7 should refer to 4, 5, and 6, not 3, 4, 5.
Yeah, that's true. That's true. We haven't changed that one. Okay. So
Happy now?
yeah. So it was actually more than formalities, yes. So you wanna take
Want me to do
that?
it?
Yeah.
Okay. Okay, so a little bit of update on what's going on in the working group. First, our second and third documents have been published. So we've got 3 RFCs out now, which frankly, I'm a little bit surprised we've gotten this far, but I continue to feel better about this group every meeting we get. So you guys have stepped up and taking something all the way through RFC publication requires really like some follow through and dedication. So thank you very much to the authors for getting these out the door. This actually was hard. I mean, for those of you who are here, there's some laborious analysis that required. So thanks. So as we talked about in the last couple of meetings, we have revised the charter. There are there's a few nits which you can see on the data tracker, but the 2 most important bits are, one, we have a new entry in our scope of work about looking at transport security protocols. The new text is here that we're going to analyze, compare, and contrast properties and dependencies of selected IETF transport security protocols and other relevant security protocols as agreed upon by the working group participants. Define a set of security-related transport services provided by such protocols. Engage with the security area to solicit feedback and reviews on all relevant documents. So, anything that crosses from the transport tribe to another tribe, like the security tribe, is always a little thorny in getting agreement, and so this took a few rounds through ISG review, but actually once we got the wording right, everybody was in support of it. So I think this is more good work. The other thing that we did, which is when we first charted the group, we were going to we set the bar kind of low. We said we were going to produce basically informational documents, and I think that everybody's confidence is higher, and I think that the focus is really, things are converging to the point that we felt comfortable proposing that the final output of the working group is going to be a set of proposed standards. So I think that's good too, that TAPS will be a standard. Not that we can force anybody to implement it, but we'll make a standard. We updated the schedule. So the security document we'd like to get done by next IETF. The MinSet document, which is I think is probably going to be influenced by the security document. So that's sort of folded in after. Brian's. To partition it. Okay, thank you. Thank you for reminding me. I knew that there was a relationship there. Thank you for pointing that out. Okay. Well, maybe in the interest of not trying to walk and chew gum, we're going to focus on one thing one milestone at a meeting. And then the remainder of the documents are in 2019, and then we figure out what happens next. So that's it for the chair's comments. Just to bring the agenda back up here so you can see it. It is awfully yellow, isn't it? I don't think that's my fault. Let's just agree. Okay, so first, Chris is going to, because he has to leave soon, is going to come and talk about the security protocols. And you sent me just PDF, right?
Yeah.
Okay, let's see if we can make that work.
All right. Good morning, everyone. My name is Chris Wood. I'm from Apple. And I'm going to give you an update on the security draft that we've been working on for a while now with Tommy Pauly, Colin Perkins, and Kyle Rose. Next slide, please. So the point of this document is pretty straightforward, similar to the transport services to RFCs that we've already put out. We want to look at the services that are provided by transport security protocols, the interfaces that these protocols happen to provide, and which we would like to incorporate in the new TAPS architecture. So the, I guess, outline of the document follows these three simple points here. We're going to go through and survey a bunch of existing transport security protocols, both within the IETF and outside of the IETF, extract what we deem the mandatory features and the optional features as well, and then identify these common interfaces such that if you were to integrate or implement these protocols within the context of a TAPS architecture, they could just kind of slide in and applications can make use of them. So they don't need to know if they're using TLS for something specific. They just need to know how to do transport security things. Next slide, please. So the scope is kind of important here for any security or any survey draft. So although the charter text says that we're going to be looking strictly at IETF protocols, the document itself considers those both in the IETF and outside the IETF, in particular because there's a lot of innovation that kind of happens with security protocols outside of the IETF. And there are many things that don't have RFCs that should be looked at if we're going to kind of come up with a new generic API that could be used by any and all applications in the future. And additionally, what's in scope, like I said, we're going to be analyzing these new transport security protocols, potentially in collaboration with the security area, to make sure that we identify what we deem is, say, a mandatory feature or a necessary interface is actually a mandatory and necessary interface, because those are the domain experts there. We want to make sure we get that information correct. What's out of scope is absolutely any kind of recommendation for which protocol or algorithm to use. We're not going to say you must use, Cha-Cha, Poly, or ADS GCM or whatever, or TLS 1.3 instead of Quick, or pick your poison, I guess. But we're also not going to be building any new protocols, because that's the job and responsibility of those that are not in the transport area. So if you do happen to find any text that resembles anything of those 2 points in the draft, please call it out and we will promptly remove it. Next slide, please. So a little bit of history here. Back in Chicago, I believe, was the first time took an action item to start looking at the security properties of existing transport security protocols. And the IETF 99, we produced the 00 version, which included just a base set, things like TLS, minimal T, which is a non-IETF protocol, CurveCP, also a non-IETF protocol, PCP crypt, and IEP2 with ESP. The next IETF, we revved it and added more things, in particular SRTP, based on DTLS, and WireGuard, also a non-IETF protocol. And recently, we just added Google Quick, and there are many outstanding issues to keep adding more and more protocols. We're trying to be as, or it's my goal to be as, I guess, to get maximal coverage with all the protocols that are in existence. And that does not make us fall out of alignment with the charter text. So expect at the next IETF, where we hope to be done, there will be more protocols here, and hopefully they will be representative of what the internet at large uses for transport security. Next slide, please. So the methodology within the draft is, I guess, fairly straightforward. We try to decouple the relevant bits of the transport security protocols that we're looking at. In particular, we tried to focus on what we consider to be the handshake parts of a protocol and the record or framing parts of a protocol. And this is important because some don't have both. For example, ESP doesn't have a handshake. It's just pretty much a record protocol with some framing. Give it a key and you encrypt datagrams and it goes to the other side. And then some protocols just don't have any kind of framing built in them whatsoever. I mentioned noise here, which is not technically a protocol. It's a protocol framework, but that's purely about building, key exchange, handshake protocols. It has nothing to do or talks nothing about how you actually encode messages and send them to the other side. So we want to make sure we distinguish between the two. Additionally, we're trying to focus strictly on the interface of these protocols as specified and hopefully soon as implemented, because there is a bit of a delta there in practice quite often. We don't care necessarily about what the implementation details. We just want to make sure that we get the interface correct. And this is analogous to the endeavor and the goals of the Transport Services draft, or the Transport Services RFC 8095. Next slide, please. So when looking at these different protocols, we're not restricting them to any layer in the stack. So for example, like ESP and WireGuard are way at the bottom, right above the internet layer. And then things like DTLS, TLS, and QUIC can exist up at the session layer. And we might even creep up as far as, looking at application layer TLS if we feel so advantageous, because that's yet another transport security protocol. But don't quote me on that. I may change my mind. So the point here being, we're not trying to focus on one particular layer because the interface for each of these particular protocols is fairly common, regardless, regardless of its position in this stack. Next slide, please. And before I go into some of the features, it's worth kind of commenting on how we envision the security protocol sort of fit into the TAPS architecture, which everyone will go into much more detail later on. In general, the goal is to kind of abstract away the specific security protocol in use inside this TAPS architecture black box here. And then at various points during the application's use of the TAPS system, use different interfaces to either configure or dynamically, tune or update the protocol in action. So for example, if the transport protocol or the security protocol calls out to the application to validate a certificate from a peer, you would do that kind of during the online connection setup phase. And then you use a different set of interfaces when the connection is actually established. You need to read and write data, or you want to get actually metadata properties from the security protocol configuration. And the API that we're striving for would map to the specific implementation API that's inside the TAPS architecture. For example, the security API that exists at TAPS layer would map to how you would drive TLS, internally. So for example, if you were to set a private key in the TAPS layer, it just would set a private key for TLS's specific use. If you were to set a specific algorithm that you might want to use for encryption or whatever, that would set a specific cipher suite in TLS internally. So applications are ideally unaware of which specific protocol is in use. They just know that I have these specific security properties. Here's how I configure them. Here's what I have to do, during connection establishment, and here's what I can do when the connection is established, and what I can do when I want to tear it down. So next slide, please. So in looking at all these different protocols, these are the relevant handshake features that came out. Obviously, if we're going to be doing any kind of authentication, the handshake must support the ability to kind of inject a private key, or at least provide an interface to a private key. So if the private key is stored in a hardware, or an HSM or an enclave or something like that, it's necessary for the specific implementation to be able to access that private key to perform a digital signature or something. It's absolutely mandatory that the handshake protocol be able to authenticate the peer, or the remote in this case, so that you know who you're speaking to. And that it must be able to validate the source of a connection. So for example, many DTLS implementations or DTLS spec provides it. I think it lists it as an optional thing to do. If it's under heavy load, a DTLS server can provide a cookie back to the client, and the client must echo that cookie back. There's a way of validating that the packet came from, some particular specific source, and it's not being spoofed and flooded with, just garbage handshake or client hello packets. So and TLS, you don't have to worry about this because you're built on top of TCP and you kind of have that implicitly, supplied for you. But because many protocols add this feature in after the fact, we consider it to be a mandatory thing that the handshake should provide. Optionally, we would like to support mutual authentication. That's not something that every single protocol does, but it's quite common. So, for example, TLS obviously provides client and server authentication. Application layer feature negotiation is also something that's quite common. So TLS provides the ALPN extension to negotiate which application layer protocol will run on top of TLS, whether it be H2 or Quick or whatever. Being able to add extensions to the handshake protocol is also pretty common, although not mandatory. So some things like WireGuard are absolutely not extensible in any way, shape, or form, but TLS, you can just extend it for days and do whatever you want, provided that no one yells at you when you present your extension at the mic. I refer back to the earlier meeting this week. And being able to kind of cache previously negotiated session and state material was also quite common, but again, not essential to the operation of the handshake protocol. It's just kind of an optimization that really helps move things along. And managing that state is also pretty important. Like if you want to be able to flush it on demand, you should be able to do that and so on.
You can do it yourself.
Sweet, thank you. Were you trying to hand that to me the whole time and
No,
I didn't realize it?
I didn't see it on the table
Okay.
until just now, so it
Sorry.
should work. No, it's all right.
From the record side, because the purpose of the record protocol is quite simple, the features that we must support are obviously very small. For example, we should be able to import or, given a key, encrypt some datagrams and send them. I kind of said the two together. You should be able to encrypt and authenticate any kind of datagram or segment here. I guess one outstanding issue or task we could address is kind of unifying the terms that I'm throwing around here. So record, segment, whatever, datagram. It'd be used to. We should agree on what these right terms should be. Additionally, optionally, is the connection mobility feature. So some, I guess, more recent record, like wire formats, for example, provide the ability to specify a connection identifier, which allows the entire session to move about if you have like a net rebinding or a four tuple change. Not all record protocols have this particular wire format, so it's not mandatory, but it is a nice thing to have. And many protocols do offer this sort of thing. So onto the interfaces necessary to drive these certain features. As I was pointing back earlier in the TAPS architecture slide, there's kind of there's really three distinct phases in which you interact with the protocol. There's the configuration stage during the pre-connection setup time. There's the active kind of interfaces that you must work with during the connections phase. And then there's the interfaces that you can invoke and use once the connection is established. So during configuration, this is the time when you actually tell the security protocol, here's everything you might need to do or might need to use in order to set up a connection. So if you're a server, for example, you might need to specify a private key. Otherwise, you can't do anything and talk to anyone. You may need to provide what your supported algorithms are and a callback essentially to be invoked if you want to authenticate or do any kind of peer validation. And you might also want to specify parameters for the session cache if one such exists. Now, all this is not necessarily something that applications would need to do, particular authentication delegation, session cache management, and supported algorithms. In practice, it would be nice if those were things that are just handled by the system by default. You have a good set of agreed upon algorithms that the system considers safe. The TAP system itself manages the session cache, and the application has absolutely nothing to do with it. And validating the peer is something that's kind of deferred to the system itself. Now, there are cases where applications may want to override peer validation, like if they're doing certificate pinning, and maybe that's not easy to do. So in this case, you might need to interface with it. But absolutely, things like private keys and identities, those are not things that are the system can just guess which ones it wants to use at random. Pull something out of the keychain hat and then use it. You need to be specific here. For the handshake bits, if you recall, the APIs at the TAPS layer would go down to the APIs of the security protocol, which drive the handshake bit of the protocol and then drive the record bit of the protocol. Need to obviously be able to send and receive handshake messages. I think that's fairly obvious. You need to be able to validate the identity of the peer, perform the source address validation. These are the two of the features that I was mentioning earlier. Additionally, providing an interface for key updates is quite useful. So for example, when the connection is established, you get an update that you have a new key available, and then TLS or the application that's built on top of TLS might extract that pre-shared key and use it for other purposes. Quick, for example, it does exactly this. And you know, the pre-shared key export interface goes along with that key update interface. So I think these are fairly straightforward. The record interface, again, because it's quite simple, the interface is also pretty lightweight. Should be able to import a PSK and then use it to encrypt application data or decrypt application data, depending on what you're doing. It would be nice if, you know, so this is not something that all, I guess, record protocol implementations support, but it would be nice if the record protocol itself kept track of what the maximum number of bytes I can encrypt with this key is, and then tell you, the application, when the key is expired, you can no longer use it, because certain cipher suites do have a bound on the number of data you can encrypt and a bound on the maximum number or maximum size of a message you can encrypt. Ideally, the record protocol kind of manages that for you, and the application is not burdened with the, you know, making sure that it's doing things safely. So having, you know, this sort of interface helps, and being able to have an interface to support transport mobility by specifying a connection identifier, whether it's one that you receive from your peer or one that you generate on your own, is of course useful for the optional feature of transport mobility.
Try again.
I broke it. Oh, there we go.
Operator error.
Okay. So I encourage you to go look at the draft. It's a survey, so there's a lot of information there, and there's certainly room for improvement. In particular, there are several outstanding issues. We'd like to kind of unify the document structure, as the point raised by Kyle. There are some instances where we don't follow the same convention in how we describe certain features and certain interfaces of a protocol, and how we kind of pull things together at the end. So I don't know, maybe Kyle's plan to work on that in the end, or I don't want to volunteer him for anything, but.
Oh, go ahead.
I'll wait.
Okay, all right. We'd also like to expand the security considerations. In particular, this is where all the output from the interaction with the security community would go, working with them to make sure that we get the text right about what we should and should not say about usage of these security protocols and whatnot, because right now it's kind of light. Another thing that I kind of alluded to earlier is, and this is sort of a bigger task, is to identify the delta between protocol implementations and their, you know, standardized, you know, what the standards say, because that will help us kind of identify any missing gaps that may be missing from the interface, and we may want to include for, you know, I guess being more or getting greater coverage and getting things more correct. Next steps, are you still waiting until the end? Okay. So next steps, because this is now in the charter, we'd like to call for working group adoption of this particular draft and continue just hammering out and adding these new protocols as needed. And there's a bunch of issues here. So if you feel so inclined to tackle one, pull requests are absolutely welcome. And I don't know if I have a link to the repository, but I can certainly circulate one to the list, and everyone can submit their pull request there. And then in tandem, commence the reviews of the security area, because we want to get that ball rolling, depending on how long it may or may not take. And I think that's it. So, Kyle.
Kyle Rose. Is this on?
Yes.
Yeah. Okay. Like I can't hear it very well from
Yeah,
where I'm
it's-
standing. It's not on.
Can you tap it? Yeah, it's on.
It's on? Okay. Yeah, very low. Okay. In the process of working on this document, I think there's one thing that's been making me a little bit uneasy, and in conversations with Aaron, I got kind of the same feeling from him. It's about scope and scope creep. And I feel like, one of the things that you said early on in the presentation was, well, we're going to cover everything, right? And it's like, well, I mean, are we going to cover every security protocol that, like, you know, some schmo like put together when they were a 23-year-old at
Route 13 will be in there for
first
sure.
year at Akamai, and, you know, That's some self-deprecating humor. But anyway, right? It's just so. Like I think I'm wondering if as devil's advocate, a better approach might be to just make sure that we choose enough protocols to analyze where we cover the set of basically where we can determine what the set of features that each of these protocols might have, and then maybe from that derive a set of shim interfaces that are required as an interface to TAPS itself, right? So essentially, if some, let's say some security protocol lacks an automatic mechanism for key rotation after a certain number of records have been encrypted,
Yep.
right? You could imagine a shim layer between that and the rest of TAPS that says, all right, at this point we are going to force a renegotiation or something like that to cover that requirement.
Sure.
So I'm just there are like two questions kind of connected there, and I'm not sure what the right way to go is, but I think that if we try to go for everything, we're never going to get this done.
Yeah, very good point. I think in looking at the implementations, that will kind of help us really confirm or deny whether or not we got the selection correct. That is to say, if we start looking at implementations of like TLS stacks that are not our own, and we find out that there's these massive features that like just are not in the standard, but everyone does, like that will kind of that's a good indication that there is a gap in the protocols that we selected, and maybe it was provided by a different protocol that was not TLS, but it's there. It needs to be covered. So I think there are the outstanding issues that are on the GitHub tracker to add a bunch of these new protocols are there's quite a number of them, and we could certainly just say, okay, for now, let's just stick to the ones we have. Maybe look at some implementations to see if anything pops up, and if it does, maybe then increase the scope a little bit. But again, I'm not quite sure that that's the right approach. I mean, people who worked on these surveys in the past, I'm of course open to suggestions. I know that we need to be sensitive to the time, especially if we want to get this done by next IETF. So
Right. Well, I mean, you could go as far up in the stack as you want, right? You were saying application level protocols. Well, does like Envoy qualify as a security protocol? Not really. It's like a communication framework that uses some protocols. It's sort of TAPS-like in a sense. But where do you stop? And it seems like what you want is to choose a set of protocols from which you can then kind of distill out what are the important features that the TAPS layer is going to need, and which protocols can be kind of retrofitted to have all of those if they don't have them natively. Right? And I agree. I also agree that like separating the handshake and record protocols might make sense because, in a sense, right, TLS and DTLS are the same protocol at the handshake layer, right? But it's at the record layer where they differ, and that might make a difference to which transport you choose when you're deciding when you're deciding between, say, messages that don't require reliability and a stream. But is the handshake really different? Are the security properties really different? Not, I mean, a little bit, but yeah, I can keep doing this for a while.
I echo what you said, and of course I in theory and in principle I agree with what you're saying. I just acting on it is not clear to me. Yeah.
Hi, I'm Brian Trammell. In favor of adoption. The question about scope, I think that we could go, and by we I mean you, I guess, because I'm not on this document, could go relatively quickly through that list of open issues and do a relatively quick judgment call as to whether you're going to get something into the set of sort of interface characteristics by adding a protocol, right? So looking back at 8095, it has a gigantic glaring omission. It doesn't talk at all about Quick, but adding Quick wouldn't actually bring anything because Quick doesn't add any new transport protocol features that aren't already in the set of transport protocols that we looked at. Yep. So I think you can go relatively quickly through that, and you can even have in the document say in scope, we chose these as representative. We looked at a bunch of other ones very quickly. Here's some references to them. They don't add anything to what we have here. I had two questions. One is a buzzword troll question from Twitter.
Sure.
Post quantum crypto ... question mark. I don't think that'll change anything.
No.
In terms of the okay, good.
Is it deployed on the internet? Is that what you're?
Yeah, deployed on the internet. Yeah, that's the right. Yeah. Well, I mean, so these things can change quickly, right? I mean, one or two events will drive that relatively quickly. We'll still be here. Okay.
I mean, Chrome's doing
We've
experiments.
been here a while.
Chrome's doing experiments with post-quantum stuff right now.
Second
So maybe.
question. I noticed there's a split between sort of handshake phase, handshake layer, record layer. This is very TLS terminology. Is this something that exists in the other protocols, or are you applying TLS terminology to the other protocols?
No, in the crypto step document, for example, we kind of rephrased everything and we referred to the handshake as the control protocol, the record protocol as the record protocol.
Okay.
I mean,
Record protocol is kind of accepted
Yeah.
terminology in the space. Okay.
But-
So handshake and record, that's fine, but I just want to make sure that that's not injecting sort of a TLSism into how you frame thinking about other protocols
Yeah.
that don't separate that way. It seems a very natural way to separate. It's like you got to get the key material and you got to do something later, and it's fine to call them handshake and record. But okay, so that satisfies me. Yes, let's do it.
cool. Aaron.
Yeah. So first, great document. Thank you for pulling this together. I'm Aaron Falk, Akamai, also co-chair of the working group. Not sure if I'm wearing my chair hat, but as a reader of the document, I thought that it's good. On the issue of which protocols to include on the scope, I think this is an area where we want to get input from the security area.
Yep.
Transport shouldn't be saying what the important security protocols are in the internet. They might have opinions that or priorities that we don't appreciate in this room. So maybe, I don't know if it's the security directorate, but let's make sure that communication happens early on so that it doesn't end up becoming a delay for the document when
Absolutely.
there's a late surprise. The other thing is, can you go to your picture that had all the different security protocols on it? No, the one before this one. So I'm trying to take that picture and now go to the next slide. And I'm trying to squeeze all those protocols somewhere into this picture. And so it looks to me like what you're doing is you're moving the API however high up you need to go so that all the security protocols fall inside it. Is that true, or is this actually not as clean as you draw it?
So in practice, we would likely go up this high, essentially. We want to include at least these protocols. Whether or not we push it up even higher is open for debate, and likely we will not. My comment about going up higher and looking at things higher up the stack was strictly to kind of tease out any other features that we might be missing.
Right. But the goal of what we're trying to do here is allow people to write applications that sit on top of this thing, right?
Yeah.
I mean, I think of it as on top of this thing because I'm a protocols guy, but I think people who actually write code think of it as a library that sits off to the side, and so they may not have as clean a separation. But I think that if we're not going to have it like sort of a vertical layering and say, we're going to give you an API and you do all your stuff above it and you call whatever you need from the network down below, I think that may eliminate some things from the list, because there might be some things where you actually, it is an application and it needs to be tightly involved in the security. I'm sort of going on gut feel here, but it seems to me like we're to a little bit, when it was TLS, okay, it's easy to see. Okay, we've got the shim that sits on top of the transport protocols, but now we're kind of working our way up. Right?
Yeah, this is definitely another area of the scope that's kind of fuzzy. Like this line is quite large.
So I'm no longer confident we're going to finish this by the next IETF, but I don't think we should slow down.
Where's the faith?
Tommy Polly, Apple. To the point of what protocols are in scope and level here, I think we should limit it essentially to the type of things we have that are like TLS or DTLS, even if they're not considered to be truly transport protocols. Generally, they're essentially just providing a pseudo transport layer with extra functionality involved in them. But the application's relationship with reading and writing on them is essentially the relationship of an application to a transport.
Do you think you could come up with a test that you could apply to a security protocol to see whether it's in or out of the set? That's what I was, in my email comments, that's what I was trying to get to.
Okay. That would be good, and we could even essentially just define that in the document, saying that we are considering security protocols that behave like transports when the application uses them.
Let's take that down in the notes. That text is good.
Effectively, that's how I think implicitly we're thinking of that in the back of our heads, but it's not spelled out.
Yep.
No, I also agree we don't need to be
Yeah.
exhaustive.
That's a separate matter, but it's good.
Right, I think we should be definitely willing to take any non-IETF protocols and put them in an appendix, especially if they are not adding anything to the surface.
Just to remind this, the updated milestone says like it's a limited set of IETF protocol as well. So it might be possible that some IETF protocol go into the appendix as well. So when you are setting up the test, you need to also come up with like it's not about only the non-IETF protocol. It might be including IETF protocols.
Yep.
According to the text in the charter. Yeah.
Yep. The one other point I wanted to bring up is how Quick had a very interesting discussion earlier this week regarding the relationship of TLS and the security layering to the Quick protocol. Unclear exactly how all of that is going to land. We do have analysis of the current IETF Quick as of like what the documents say today in this document. If that's in flux, I'm not sure how we should reflect that in the document.
Yeah.
So
Good point.
I think an easy way to deal with this is we get it as far as we can, and then we let the document rest.
Yeah.
I don't think there's huge value in pushing it through as an RFC as
Yep.
soon as possible. I want to get the work done so we can move on and make
Great.
sure that the API stuff incorporates what we know, and we can go back and revise it later. I don't see that as a problem.
Great.
Also, I think the Stream Zero problem was, I don't recall correctly what the text was or what was said in the meeting, but my understanding was that they would hope to have this kind of resolved by the next IETF. So, maybe the two will align and this text will solidify itself and we can just kind of stick with it and go with it. Whether it be we now layer on top of DTLS or we stick with what we're doing. So, yeah. Maria.
Yeah, Kulevint. Regarding Quick, I mean, the crypto protocol for Quick is still TLS, right? So that is covered. The handshake, yes, the handshake is the same. The record layer is not the same, but probably all we need to say is that this architecture exists, right? That which will not really change. We don't need to go into further details about Quick.
I don't recall exactly what it says, but we'll probably need to wordsmith it a little.
I think we're about out of time for the segment, so maybe
Oh,
we should
right.
move on. But
Cool.
you were going to be short.
I thought so, yeah.
Well, you were. It was all the discussion. So
All right.
Thank you, Chris.
Yeah, thanks.
Okay. Okay. Next on the agenda, Michael Welzel. Michael, do you need me to show your PowerPoint, or can I show the PDF? Okay. Oh, I think I've got. Are they the same? Because I've got the PowerPoint queued up. There we go.
All right, that's I think minimally, minimal time presentation with a minimal number of slides for a minimal document. Next slide, please.
Yeah, you got the picture right there. Oh, yeah.
Thanks. I'll do this. I already lost a couple of seconds here. Okay, so two updates happened to this document since the last meeting, and I will classify all of them as editorial. So this was the first one was addressing the comments we got at the last IETF, and with a few emails later. For instance, one comment was that we should not talk about falling back to TCP and UDP, but regard them, as members of a set. So this is just a text change, really. It doesn't talk about fallback to TCP or UDP anymore. It says implementation over. It's a kind of intelligent search and replace operation, right? Because it's not exactly everywhere exactly like that, but doesn't say falling back. Removed references to both post sockets that were in there that did say that post sockets requires a system on both sides to function, because that was my understanding of it at that time. And the replaced flow with TAPS connection, which again is on the next slide changed into something else, but that was for this update. And frame with message. So the point was here to try to avoid introducing new terminology that had been introduced to essentially convey that there is a higher level notion of a connection in TAPS that may actually be a stream of a transport or a connection. And sections 3 and 4 were made in line with the categorization that's already used in the appendix, and this RFC 8303, and we changed the style of section 4 to be shorter, less interface-like, and updated the reference. And then came some comments from Miria. asking to replace, well, to get rid of some extra terminology. So there is no more the TAPS system and the TAPS connection. This is now really replaced with transport system and connection. I think the document doesn't actually use any new terminology anymore now. Just refers to the uses words of the protocols that it is based upon. And section 3 and 4 I finally managed to really merge together into one section 3. And then there were a few editorial nits, and that was it. What next?
So one question, going back to the discussion that we had, my misstatement about the MinSet earlier, is there anything in the document now that talks about, that might link to a separate discussion about security protocols?
No, so there is text saying that there is some text in the appendix deriving things related to security that are there, in the protocols, authentication and so on. Then there is text saying that in the MinSet that is being proposed here, this is all excluded because there's a companion document talking about security. And it references that.
So I don't think in the security document there's any discussion of what a minimum TAPS implementation needs to support. Do we? Okay, so do we think that that a minimum TAPS implementation must support some security protocols in order to be called TAPS? If we're going to say that, if we believe that, we should say it somewhere. This document is one place to say it, or we could say it in the security document and then put a statement in here that says we address the minimum security requirements in this other document. But it seems to me that if we believe that if you're going to do TAPS, you have to support some security protocols. We have to say it somewhere.
Brian Trammell, eating the mic. I think we do need to say that it's an implementation requirement. Given sort of the pattern of the rest of the documents, we're kind of putting security on the side afterward, and then we're going to tell people don't put security on the side like we did in these documents. But the most logical, so draft, is it draft Wood or draft Poly? So the document that Chris just presented seems to basically be 8095 plus MinSet for security, and I think that we should do it that way, right? So the recommendation on security should be there. MinSet should have a reference to the security document and say,
which it does.
Yeah. So I think we're fine. I don't think we need to bring this stuff back.
I think the
nice separation.
Specifically, the reference should say the minimum requirements for a TAPS system are specified in this other document.
Yes.
Right.
Well, the minimum security requirements for TAPS are specified in this other document.
It doesn't say that now, but that's
it should say that. But
that I'm fine with that.
Sorry, just to clarify, Kyle Rose, just to clarify, you can imagine, I just want to know what the thinking here is. You can imagine a system using TAPS that has sufficient security built into it, right? That it only needs a way to get packets across the internet. Is that intended to be supported here, or are there going to be minimum security requirements on every transport that will essentially require, say, double encryption or something like that?
I don't think I should be answering that. I mean, others having stronger opinions about these things. So the general
Tommy's giving me this look, so maybe I'm not being clear. So I'll talk with him about it offline.
Yeah, because there's a way of to derive what is supposed to be the minimum in the minimum set, and that applies to the things there. But then security stuff is pointed at the other documents. So I think it should be done. Decided. Yes.
Philip Teasel, TU Berlin. Sorry. For the usage document, we have a separate. So this is actually not a question towards the MinSet, but rather to the security draft. For the usage documents, we have a separation now. We have a separation between MinSet and usage document for the, let's say, non-security features. Do we need the same separation for the security features, or will this be just one document covering both?
Yeah, that was the thing that I was trying to explore, and what I got from the people who've been working on the other document was that one document could cover both. I don't see a lot of value in having two documents. I mean, if it's two different sets of people, then it might make sense, but that's my personal opinion.
I think we should just clarify this.
Okay.
I have no opinions for either one.
Mm-hmm.
Tommy Polly, Apple. Yeah, I think looking at the security set, what we've distilled and what Chris presented is, I think, a lot smaller than the set of all of the transport features that were analyzed. It's already more minimal, so I think it requires fewer stages of distillation. Had we encountered the same thing with the transport features between UDP, TCP, SCTP, etc., and they had all come together more neatly, then we wouldn't have needed all the documents.
Mia Kulevind, I have a separate question. So the decision tree in the diagram, what's the plan for that one?
Oh, it's the plan is to stay as an example. It's just how, to give an idea of what you can do with these things, or how you would make to have a decision in the beginning. I think just putting a list there doesn't help anybody really to understand how you could choose the protocols.
Okay, so it's meant as an example because that's
Yeah.
not how I read it, but I can look at it again. Yeah.
I can, if it doesn't say example, then I include example, but that's the meaning.
I just wanted to go back to the previous the conversation to reiterate. I think that one of the reasons we did the sort of three-stage documents is that we didn't quite know what the process was going to be for making these decisions when we started. So it's like, let's do all the homework. And one of the things that has come out of this process is we understand how to do the process now, right? And we understand how to say, okay, well, from the large to the small. So I really think the security thing can be faster. I share Aaron's skepticism that it'll be done before Montreal, but maybe right after.
Yeah. Okay. Sounds like we're having an agreement. So I think that I guess my conclusion from the status is, sounds like you're done. Should we last call this document?
Please.
Okay. Can I?
Yeah. Two
Yeah, with
updates,
the
like
updates.
making
So
sure that the decision tree is mentioned as an example if it isn't, and your phrasing of the point to the security document.
Yeah. Okay. Let's
So
take a
that's,
hum in the room. Who in this room thinks the MinSet document is ready for last call? Who in this room thinks this document is not ready for last call? Who hasn't read the document? What? Okay, so I think we'll do a working group last call. That might cause people who haven't looked at it in a while to look at it. And thank you, Michael.
Thank you.
Well done. I thought we had adopted that. Am I mistaken?
We haven't submitted it.
Well, it seems like that's kind of an important call for working group adoption.
Yeah.
Well, yeah, well, that's right. We needed it in the charter. Now it's in the charter. Now we can adopt it. Okay, let's take a hum. So a hum for people who think that we should adopt the security document in this working group. Okay. Hum from a people who think we should not adopt the security document. Hum from a people who have no idea what we're talking about. Okay. About what I expected. Okay, excellent. All right, Tom, can you make sure that gets into the minutes? Thank you. Okay, I'm running one. Yeah, right. We'll take it both. We'll take it to the mailing list as well. Thank you for reminding me. Okay, are we on time? Let's see. It says 45 minutes, and we are about 5 minutes late. Okay, so did you need me to show your Keynote slides, or is PowerPoint's okay? Okay, then let's see if I can. Oh, but guess what? That's what I've got. Let's see what happens when I fire it up. Okay, play, slideshow. There you go.
All right. Hello, everyone. Thank you. I'm Tommy Polly, and this is going to be the first of a trilogy. So we have 3 new documents that have been published, and these are all aimed at the milestones coming after MinSet and coming after the Transport Security Survey, trying to synthesize all the things that we've learned from the surveys and MinSets, etc., and unify the approaches to how we go on from there. So again, as we said, there are 3 documents. This is the first one. It's just about the architecture, fairly high level, aimed at introducing everyone to these concepts. So to recap from last time, there was a lot of discussion about what are we going to do about what was milestone 3 at that point. So that last milestone is all about how do we define mechanisms to allow a transport system to be actually deployed, to be defined, to be used by applications. And as of last time, there were several documents which were all in this area describing various aspects of it. So we had the NEAT document, which described the whole NEAT system. We had the post-sockets document, which was the bright new vision of how we go on beyond sockets. I had a document on guidelines for how we do racing of various levels inside an implementation between racing endpoints, paths, etc. Happy eyeballs on steroids. We had the other TAPS Happy Eyeballs document, which went into just how you're racing the protocols, especially for SCTP and the experience done there. And we also had the socket intents about how applications can specify the preferences and types of properties they want from their transport to end up selecting the correct transport and the correct path. So these are all very related. They all covered different parts and all had useful things to bring to the table. So how do we reconcile these and combine the efforts? So we sat down and thought long and hard about it, and we roped in all of the authors from those documents to try to get together and hammer out something. So the proposal, and this was taken to the list back in January, I think, was to distill the work from these into 3 new drafts. One being the architecture draft. This is to explain the whole approach. What are the basic concepts? I think of the audience here as essentially the IETF community, anyone coming to this with new eyes, essentially. What are we trying to approach here? There is the interface or API document, which explains in detail how the applications that would be using transport services actually use this system. What is the abstract, non-language specific API into this? And so the audience there mainly is developers who want to write apps to use transport level services. And then there's the implementation document, which I think covers a lot of things that had been lacking in the previous descriptions, to explain really in detail how do you actually implement a system such that you take this interface and you apply it into real code that is actually taking the protocols and looking at how do we apply these various interface aspects to each protocol and to each approach as we are doing racing of protocols, etc. So that's what we decided to do. So the architecture draft mainly has 2 parts in it. It's relatively short compared to the others. It has a design principles section, which covers the constraints on the approach. What are the guidelines we've given ourselves when working on this to make sure that we're coming up with something that makes sense, that's reasonable, and also future-proof. And this is based on the surveys that have been previously done. It's based on the min set, and it expresses essentially that history there and what we're trying to do. And then the second section is more just like a list, laundry list of concepts and terminology that define the framework that we're working in, that define concepts that hopefully can be used both in the API documents and the interface document, and potentially may seep into implementations as they develop. And so the API concepts are things that are concepts that we expect to be exposed to the applications. And then there are concepts that we believe, at least at this point, are more specific to implementations and not really driven towards applications, but contained within a TAP system itself. So for the rest of this, I just kind of wanted to go over what our principles and concepts are so that we can all have an introduction to them. If you have any thoughts, clarifying questions come up now. If we have general discussion, we can leave that to the end because we're going to do 3 presentations here of the whole sweep. So the first principle is that we want common APIs for common features between protocols. This is pretty simple. I think this is very much in the spirit of what TAPS has been about the whole time. So when we have a common operation across multiple protocols, we should be using that same API for these common operations. Something as simple as when I need to send data over my transport, it should be the same send call whether or not it is TCP or TLS. The goal is to write your code once and reuse across multiple protocols. That doesn't necessarily imply anything about are these things switching out underneath me, but I want to just write my basic code for how I use my transport a single time, and maybe it automatically switches over to some new protocols, maybe I recompile with new options, but it's the same code. And this common set must at least include the minimal set defined in min set. So that's principle 1. Principle 2 is that we do need to provide access to specialized features, and the way we do that needs to be carefully done. So if you have a non-generic protocol option, it does need to have some way to be set. Otherwise, a lot of applications will not find this very useful if they can't set their UDP checksum specific option. We want this to be not less useful than sockets or older interfaces. However, the protocol-specific features do need to be exposed in a way that they do not limit protocol selection or protocol flexibility going forward. One way of doing this is to say, if you need a protocol-specific option, if you use that protocol, protocol X, use the option specific to that protocol. But do not prescribe on the entire connection, you must use datagram checksums. Only say if you use UDP, you need this feature. Certain specific features, however, like I could say, I need security on this. I need to make sure this is at least using AES, blah, blah, blah. Those may end up limiting protocol selection because there are important ramifications that come from degrading your security. Third principle is just talking about the scope for the API and implementations going forward. So the API must include at least minset. So we have to be able to do basic TCP and UDP operations here. However, not all implementations must implement all of the protocol features. So you could imagine there could be some IoT devices that don't want to actually implement TCP or TLS because they're really lightweight. But the API that they provide, if we want it to be common everywhere, should still express, oh, you could ask for TCP and it would just not give it to you and it would fail. The API should also hold back and avoid referencing any specific protocols. We want to make sure it remains general and protocol agnostic going forward. And the implementation is the thing that's responsible for defining the mappings of the API onto specific protocols, which we imagine can be extended over time. We can have future definitions of how you map quick version 100 into this API. And of course, there are no new protocols being defined in this effort collectively, and there's also no requirement to use a TAPS system on both sides. This is just a one-side API to make sure that we can take advantage of the existing set of protocols. So getting into the concepts, here's a basic overall architecture diagram. I think this may come up a couple more times in some of the other slides. Essentially, we have at the top a application and a series of categories of APIs that it's working with. It has several phases. It has a pre-establishment phase in which it has to do the setup. It has the establishment phase in which it says, I want to actually activate this object, whether it's a listener or a connection. It can do data transfer, which is clearly the goal of a lot of our transport networking. It can terminate things. And then there's also the phase of receiving events from the transport system up into the application. So that essentially defines the phases of the API level. Down below, there is the implementation, which has concepts such as gathering all the candidate paths and endpoints, racing them, having cache state, involving system policy in this whole decision-making process, and building up protocol stacks. So that's kind of the high-level view. Should be fairly straightforward. It maps well onto things that we're all familiar with, like TCP, UDP systems. All right, so just running through a couple of the concepts here. These are the main highlights from the document. First, we have the basic objects that we imagine need to be interacted with. First, there is a pre-connection. This is a interesting term that was come up in our various debates about terminology. It's essentially the properties and parameters that can be specified to define what a connection or a listener can be. It's the endpoints and properties that the application wants, but it doesn't actually do anything on its own. A connection is the name that we're using for the basic object that can be created from those properties and is an active object that can be used to send and receive messages between a local and a remote endpoint. And this is, we're using the term connection, but it can still, of course, apply to things like UDP that on a protocol level are connectionless, but this represents the active state that the application is aware of to send and receive messages. A listener is the passive receiving object that allows you to receive incoming connections. So then the concepts for the pre-establishment phase, we've already mentioned briefly, there are local and remote endpoints. These represent the things that I can define my identity and also define the identity of the things I can talk to. There are path selection properties, which is a whole set of properties that define which paths, so which interfaces, which addresses, etc., the application wants to be able to interact with. There are protocol selection properties, and these are the properties of what services I need my transport to offer, such that we can select the correct transport protocol for you. And finally, there are the protocol-specific properties, which are the ones I mentioned earlier, saying, oh, and if you use protocol X, make sure you configure it in this way because I know my server only is expecting that particular bit. These do not alter the protocol selection. So during the establishment phase, pretty simple. If you have an active connection, you can initiate it. And if you have a listener, you can listen on it. We do imagine that as we are expanding this, we are going to include a couple more actions for things that are doing multicast and other styles of connections, but we're starting with the limited set that everyone could agree on. For the concepts for data transfer, of course, there's send and receive, basic concepts. The broader one over that is that we are communicating in sending and receiving messages. Messages are units of data that can be sent and received, and they are in order to themselves. The boundaries may or may not be understood by the underlying protocols, but having this concept is very important to decorate the messages so we can essentially say, here are the properties of this particular piece of data, such that when we have protocols like SCTP or QUIC that may have more ability to do interesting things with those pieces of data, we're able to take advantage of those. But it does still map well into a system that's using just raw streams like TCP. As far as events, we have things like connection becoming ready, which means that's essentially, it's connected. You can read and write on it now. Things like it's failed. It's now the connection has ended. You can have events that your message has been sent and a message has been received, and these can deliver errors or deliver the actual data that you've received. And then there are events like path properties change to let the application know if it needs to that some properties of the system it's working on have modified underneath it. This is especially relevant if you have something in which I need to change the quality of the streaming I'm doing because I'm now on a different interface than I was before. Sometimes the applications will need to be involved in this. And finally, we have concepts for terminating connections. You can close, which is the generic graceful teardown of a connection. And it may involve communicating to the remote endpoint that we are done with this. It may not. And we also believe that it's important to have a concept of an abort, which is more immediate teardown and involves not sending any outstanding data. Let's get rid of this quickly. So that covers the API concepts. As far as the implementation concepts, we are defining here the steps of candidate gathering, which is all about filtering out the protocols and paths and endpoints that are allowed based on the application preferences and the system policy. And this is elaborated much more in detail in the implementation draft. We have steps of candidate racing, which means that fundamentally, when we're bringing up connections, they are happy eyeballs based. They are flexible in what they're trying. They're trying multiple things. We also have the concept of connection groups. This is for things that are being multiplexed, whether it's SCTP streams, quick streams, HTTP2, etc. These are connections that have similar properties and allow the underlying TAP system to turn them into multiplex connections. And that's essentially it. That covers the architecture. If there are any clarifying questions now, please come up, or we can just go into the details of the interface and implementation.
Yeah, I prefer to try to hold all the questions until later.
Sure.
Because clarifying questions often
All right.
get out of control. Thank you very much, Tommy. Okay. Look at that, it just works. View. screen. Dongle is right here.
Hi, I'm Brian Trammell. It's actually weird sitting next to Aaron and not trying to do a presentation in 6 minutes and 20 seconds. So I'll try to slow down a bit.
Make it fun.
You've already seen this because I stole it from Tommy. This is the architecture diagram. The point of this interface document is to essentially take the architecture that we worked out in that document and the principles, the architectural principles from that document, and to sort of project them into an abstract interface that you could actually implement in any given language in order to meet the transport services architecture. So we had some design principles. These are derived from, but functionally separate from, the design principles from the architecture. We want to define a single interface, so this meets our requirement of write once, run over multiple stacks, to be used in a variety of application design patterns. So we're not simply interested in client server or sort of single threaded, hey, I'm going to do this hello world type stuff. We want to do sort of everything that people do with networks to enable applications written to the single API to make use of multiple transport protocols in terms of features providing, one, explicit support for security properties. Sort of we're catching up with the security document and saying security is actually whether you turn it on or not, turn it on or not, it's part of the transport layer. For asynchronous connection, transmission, and reception, the requirement for asynchronicity comes from the fact that you can't actually do a lot of the cool stuff in terms of connection racing or path property, path selection, any of the things that you want to do in order to make TAPS work doesn't really work if you're doing it single threaded in terms of first I'm going to go do a get adder info and then I'm going to go do a socket and then I'm going to go do a connect. Support for multi-streaming and multipath transport protocols. So we put this in here because it actually wasn't quite yet captured in the architecture, but a lot of the interesting developments in the transport layer right now are in this space, in sort of like, so quick, MPTCP. And atomic transmission of data. This is also interesting for being able to take a chunk of something that you want to send over a transport and say, all of these bytes somehow belong together. Please make sure they get there on the other side. This is necessary when you're building applications on top of these multi-streaming and multipath transport protocols. There was a lot of discussion in previous TAPS meetings about how exactly this works, and we think we have a way to make it work. We'll talk about that in a moment. So when we take that architecture diagram and push it through those principles, we end up with an interface diagram that looks like this. So these up here are the phases, and then we have sort of the pre-establishment involves sort of figuring out what the properties are, the endpoints that you're going to connect to, and resolving those, taking the parameters for selecting a connection, binding that to a pre-connection, and then taking that pre-connection and turning it into a connection. So endpoints, and here I have actually references to the document. For those of you who haven't read it yet, you can actually just go through this presentation. You don't really have to read the document. And when you do read the document, you want to check to see where I got things wrong in my slides. That's the section reference. We want to be able to specify remote and local endpoints at a variety of resolutions. You might actually have application logic that says you need to connect to this IP address. Generally will be doing things in terms of domain names, but in sort of in other environments, you have other ways to specify things, right? The resolution here is under control of the transport services system, not application control. So this is a departure from BSD sockets in that now there's sort of a explicit phase for resolution, get adder info, followed by an explicit phase for doing something with the struct sock adder. And we don't want to do that anymore because you can't do a lot of the cool stuff we want to do in TAPS if that's your pattern. This is bound to the pre-connection because the pre-connection has properties that may do some pre-path selection, right? So for example, if you're doing resolution with the DNS, the answer you get depends on the resolver and the source address that you present it. So you need to actually do multiple resolutions depending on the selected protocol stack, depending on the provisioning domain, depending on other properties of that interface. There is an open issue that we need to address here. When you put this under the control of the transport services stack, some applications may actually want control of when the resolution happens, because DNS queries can leak interest about things. You might actually want to say, okay, well, I want to check over here first, and only if that fails, I want to check over there because I trust this network more. We don't have an answer for that yet. We have a space of answers, but we need to sort of pick one. Yes, of course. Otherwise, we can just go home. Transport parameters, section 5.2. Here we have sort of properties that you can use to select both protocol stacks and paths. And these are essentially used to select or prefer or eliminate candidates while you're trying to do connection establishment. These are the old slides. Okay, good. They're mostly correct. These properties are partially, there's a missing partially right there for Michael, derived from MinSet. Whether or not the protocol stack provides reliable data transfer, preservation of ordering, whether or not it provides the ability to select reliability on a per message basis like PR SCTP, whether it provides zero RTT session establishment, multiplexing or multi-streaming, whether you can get retransmission and ICMP notification as in SCTP, control over the checksum coverage for doing partial checksumming or checksum disabling for UDP and UDP Lite, a capacity profile, which we can talk about in the discussion, and then sort of path-only interface type information. Aaron.
Oops. Yeah. Do you want me to get the other deck of slides?
No, this is fine. There's only one. I can actually give you a URL to throw up, because basically I just say, hey, we have issues. Please go to GitHub, but I'll tell you that when we get there. We have these protocol and path selection properties. Separate from that are protocol properties. If you have suggestions on the terminology, we are very open to them. These are protocol properties allow us to configure and query information about a running protocol stack after it has been selected in a transport independent way. So here we have relative niceness. This is a post-sockets concept. Niceness is essentially 1 over priority. We have the transmission scheduler for the group. We'll talk about groups in a second. The connection abort timeout, notification thresholds, checksum coverage, minimum and maximum sizes for how we deal with framing. The idea here is to have, for the MinSet, a set of protocol properties which we don't need to know anything about the transport protocol to set. The architecture's requirement to be able to reach down into the protocol when you really, really need to is provided by sort of specific protocol properties, and these are essentially namespaced by the protocol. So you would set a specific protocol property on TCP, and if TCP happens to get selected, you would configure TCP with that property. Otherwise, it wouldn't get selected.
Now that I'm staring at this, I'm wondering why the properties itself are discussed in the API document and not in the implementation document.
So the point of putting it in the API document is to say these are the things which you as an application developer will have control over in the minimal state, right? It's the abstract part.
Yeah, but it depends on what the application actually implements at the end, right? Or are we assuming that these are the mandatory ones?
We are not assuming that yet, right? So these are the ones that would be common, but not necessarily mandatory.
Okay, I'm going to give one short comment to each of you, and then we're going to defer the rest until the open discussion part.
Tommy, just to Miria's comment, the implementation draft, I think, is much more focused on things that are hidden from the application, right? So these are knobs that the application may or may not have to interact with. They're totally optional knobs, but they are still knobs.
Kyle Rose, yeah, I'm thinking that this is like essentially a set of suggestions of things that you could implement using, say, a cascading style sheets type mechanism.
Yeah. This is the CSS thing.
Right. Okay.
Michael, I think we should clarify that they're optional to use for an application programmer, but not optional to offer. So I think that's the set of knobs that we really want.
Yeah. So here right now we haven't actually said must, should. We haven't put normative language on these. We need to do that in a future revision. I think what we're asking today is this the correct approach? Not is this the correct list of things? I mean, we need to go on the details of that, and we need to actually back that up with stuff in the implementation document. These are 0 revs.
So I'm going to defer the rest of this discussion until the open discussion part because we have a lot of material to get through. So I'm sorry.
Yeah, we're
Please sit
running out of
down.
time.
Try to remember your comments. We'll come back to it later.
As you see, we have we may need to revisit the organization of the document because I just jumped from section 5.2 to section 9.1 back to section 5.3. So this is what's in the security parameter section of the document right now. Actually, looking at Chris's presentation this morning, the security parameter section does need to be updated to follow the minimal set that comes out of that document. But here we have, again, generic security properties that allow you to do, it's exactly the same thing, right? Like, so you have a transport independent way here, and then you can configure and query security features in a protocol independent way. This identity, private key, the group's algorithm, cipher suites you want to use, configuration of the session cache, pushing pre-shared keys into a session, and then callbacks for trust verification identity challenges, right? So these are standard things that are partially derived from that work, but we need to sync it up. There are a few more things that need to go in here. Huh? What? Yeah, for example. So now, following the structure of the architecture document, we go through the different parts of sort of the usage of this API in terms of their phase, right? So phase, the pre-connection phase, the pre-establishment phase is all involving a pre-connection. So this takes some endpoints and some parameters, and one of the purposes of giving this to a pre-connection is so that the system can prepare cache information, pull information out of the cache before it actually does the establishment, right? So this allows the system sort of in the background to start preparing for the fact that you're going to ask for a connection on this. You can also group connections before establishment. We'll get into that in a second. And recognizing that this can get a little bit clunky. For many applications, you might want to let them just say, hey, I have some parameters, give me one connection. I'm only ever going to need one connection. We can have sort of convenience calls in the implementation of the API that says, okay, I'm going to pre-connect and then I'm going to connect at the same time. Because one of the goals here is that we want an API that doesn't look, much more Byzantine than what people are used to right now. So once you have a pre-connection, you can establish it. There are 3 ways to do this, sort of active, passive, and neither active nor passive, or both active and passive at the same time. And each of these has an event associated with it when the connection is done. So if I want to initiate, then I get a ready event. If I do a listen, then the pre-connection becomes a listener, and I get a bunch of connection received events. And if I'm doing a rendezvous, then basically there's additional information about how that relay is going to happen. If there's NAT traversal, it needs to happen. And then once that channel is established, you get a rendezvous done event. Once these are created, before these events fire, these are still real, actual connections, and you can do everything that you want to do with a connection. With these connections, you won't receive any data on them because there's no way for the data to get to you, but you can start throwing stuff into the buffer, and you can start enqueuing receive requests. The details of 0RTT are still an open issue. There's a big long thread in GitHub among the authors. We have not figured out exactly where we want to push that ugliness, but the ugliness is essential. The way that we represent multi-streaming protocols in an environment where you may or may not have access to a multi-streaming protocol is with a connection group. This is a neat concept that we've kind of slammed some post sockets into. So we have a sort of a unified way of dealing with this, but it's inspired by the neat approach. You can take connections and you can entangle them into groups. Once a connection group or connection is entangled into a group, all of the protocol properties of that connection move together. That represents the fact that these logical connections may just be streams in a multi-streaming transport protocol. They may have one sort of like lower layer connection among all the connections in the group, or they may be implemented as multiple flows if you don't have a multi-streaming protocol available to you. The way that you create a entangled connection, so the group itself is not created explicitly, it's created implicitly by creating new preconnections that are cloned from existing preconnections. So if you take a preconnection and you clone it, every initiation you do off of that off of the entangled set of preconnections will be part of the same group. You can take an existing connection and you can clone it. On the other side, if the underlying multi-streaming transport protocol supports notification that a new stream is available, that shows up as a connection received event. So as far as the application on the listener side is concerned, it's just a new connection that popped up. There are details in how you would handle this when you have a single stream initiated by the initiator in a client-server architecture, where then the server would initiate new streams. That's an open issue, and we need to handle that as well. Sending data, pretty easy. There's a thing called connection.send. Not super exotic. There is sender-side framing. So if you're in a environment that basically allows you to deal with arbitrary application sort of data types, you can hand that data type into send as opposed to doing the serialization inside the application, and take the serialization and move it down into the API. So you have the application has the ability to say, please frame my data like this. This is kind of a convenience function, but it could be used, for example, to frame data differently in case different protocols are used, because there is a requirement for different framing in different protocols on the other side from the server.
About 4 minutes.
Okay. How many more I got? Yeah, I'll finish off. The per send behavior can be controlled by some send parameters. So again, we have lifetime, how long. If I'm partially reliable, how long should I wait until I give up on this? Niceness is again inverse priority. Whether or not it needs to be ordered with respect to the last send on the same connection, whether or not it's idempotent and can be used for zero RTT, and then checksum coverage, immediate acknowledgement, and then sort of this instantaneous capacity profile, which we'll talk about in the discussion later. Pretty much anytime you do a thing with this API, it might yield an event. Here that would be sent. Hey, as far as I know, this made it to the other side, depending on what the underlying protocol can give you as far as how much send information, about how far it got sent. Usually this is it got put down to the kernel, so it's not TCP-ACK. No, actually, so if we have TCP-ACK notification or a protocol that gives us ACK notification, we probably want another event here for delivered, but that's not there yet. Discussion, Gory, or not, right? So these are all you can see that there's a common theme of there are open issues. This is a 0-0 document. We have among the author group, we have pretty good agreement that this is the right approach for this. We want feedback on whether or not we're barking completely up the wrong tree, but like all of the little details we want to do under working group change control. Receiving, amazingly, this is called actually connection.receive. So the application essentially registers that it is ready to receive data by calling receive, and then it gets a receive event. This is a way to allow sort of application pushback for essentially flow control. This message is going to contain an octet array as well as some reference to some transport metadata. So if the underlying stack gives you the ability, for example, to see the ECN status of this packet, you could actually get that out of the metadata. How we generalize and make specific that metadata is an open issue. Okay, thank you very much. There's a detail here that we actually worked quite hard on, in that this API gives you atomic reads. When the underlying transport protocol gives you message framing and boundary preservation, like SCTP, then that atomic read information comes down from it. You do a send on one side, it gets put into a framed thing on the transport protocol, it comes out of the transport protocol framed, you deframe it, and everything is fine. When you're running over something like TCP, when you're running over something like TCP, you need to have some knowledge of the application protocol running underneath it in order to deframe it. Turns out almost every application protocol that runs over TCP has its own framing mechanism because it needs it, right? This is an indication that this is actually a missing transport protocol or missing transport layer feature that we're adding back here. So just like the sender side framing, the sender side deframing allows you to push that down. Closing, you can close connections. You can also abort them. One of them is orderly, one of them is not. When you take all of this stuff together, you get this. So you have the parameters, you can run them at 5 different levels of, yeah, my timer is done. Any questions?
No questions.
No questions.
Questions later. Questions?
Yeah. Anna.
So, is that all the material, Brian?
That's all material. Yeah, I'm missing the other slides.
I think we may have already seen some of those. Thank you, Brian. Okay, Anna.
Yeah, here you go.
Okay.
Yes. Okay. Hello, everyone. So I'm Anna Brunström, and I'm here to present the third document in this document set, Implementing Interfaces for Transport Services. And as already introduced by the previous 2 speakers, this document complements the architecture and the API draft. So it provides guidelines on how you can implement this type of TAPS system. So in relation to the architecture that we already have seen, this document deals with this part, the implementation, how you can do the gathering of candidates, the racing, how to use policy and cached state, and how to then implement pre-establishment actions, establishment, data transfer, and termination. So the first part is the application. The implementation needs to support the basic objects that are defined in the architecture. So the pre-connection is implemented as a bundle of the different properties and the objects that it contains. An important part for the implementation is that when this pre-connection is turned into a connection or a listener, these path selection and protocol selection properties becomes immutable. So the implementation needs to ensure that they do not change after this point. So moving on to the first phase, the pre-establishment. So as you already heard, in this phase, the application provides its endpoints, and it can give the preferences regarding the protocol and the paths that it prefers to use. So the implementation then stores these objects and properties as part of its pre-connection object. And you also have a lot of these protocol and path selection properties. So for the ones that are not specified by the application, the implementation needs to use the default values that is part of the API. One part for the implementation is also that during this pre-establishment phase, you can also do early failure detection. So if the application gives you path or protocol selection properties that you cannot support because you know as an implementation what protocols you have, and if they are not supported, then providing an early failure notification can be beneficial here because then you can save resources. And similarly, if you request properties that are not compatible with each other, that implementation can generate an error. So an important part in the pre-establishment is that you get all these properties and preferences from the application. And the implementation needs to take these together with other inputs. So you have some dynamic system policy where you, as an implementation, can gather information from previous connections, or you can gather information from other sources external to you. And you may also have some default implementation policies. So a key thing for the implementation, and one of the main benefits of having the TAP system, is that we dynamically can make these decisions to give an optimal transport performance. So any of in the implementation, you also have to ensure that the constraints that are given by any of these input parameters all have to be satisfied. So you cannot select the protocol that doesn't follow the requirements from the application or that violates your system policy, for instance. So for implementing the connection establishment, as you already saw in the architecture overview, there are 2 main steps to this part. So it's the candidate gathering, where you identify then which possible paths and protocols and endpoints can you use. And this is also where you use this system policy component in that step. And then you have the raising of these components when you try them out and see which ones you can actually establish, and you provide them one of them back to the application. So this is quite a large part of the description of the current implementation draft. And this comes a lot from Tommy's draft on that topic that was also presented in the previous meeting that we had. But for the candidate gathering, you can describe the candidates by in a compact notation by the endpoint, the path, and the protocol. And you can then also structure these available candidates as a tree. So if you have in this case, you have the endpoint and you have any path available, you can then split that up depending on which path you select. For instance, you have Wi-Fi and you have LTE, and then you may also have for Wi-Fi just one endpoint, IPv4 address, but you may have for the other LTE, you may have both IPv4 and IPv6 endpoints. So you can structure all your choices as a tree. And this is kind of how you can represent and have all the candidates that are possible to use. And when you construct this tree, the order in which you branch is quite important. So Brian was already talking about this, that it's important that you do the DNS resolution, for instance, on the right path, so that you don't get candidates here that doesn't make sense to use, actually. Also you also then need to sort the branches. So this is kind of how you give the preferences for the different protocols and the different paths. And this is, again, then based on your system policy. So once you have gathered all your possible candidates, then you have the raising of those candidates. And you have different approaches that you could apply here. You could raise multiple candidates in parallel immediately. This is not that you should. You have a clarifying question?
Clarification, yeah, Lorenzo Colidi. So I'm trying to understand if the previous slide and this slide occur in two different time phases or not, because it seems to me like you can't tell that LTE 192.0.2.1 is you can't tell that and without doing a blocking operation. And so I'm trying to understand if you first gather and then you have to do a DNS lookup, right? So if you gather first.
I think it's conceptually they are separate issues, but implementation-wise, they happen in parallel, right?
Sort branches basically gets resorted every time new information. Okay.
Colin Perkins, one of the open issues we have with this draft is how to resolve all that sort of discussion, the happy eyeballs, the ICE NAT traversal, and figure out the right phasing for it.
Yes. And we have that kind of as a separate part also in the document at the moment that needs to be integrated. So I think I have that on a later slide.
You're about halfway through your time.
Okay. Yes, then we have the candidate raising, and you can do it in different ways depending on if you want to have a delay between the candidates or you want to wait until a failover happens. And the raising completes once you have one candidate that succeeds or if all of them fail. And one aspect here, of course, when you have a TAP system is that the success here is different depending on what protocol you use. So if you have TCP, for instance, it's quite natural to think that you succeed once your handshake succeeds. If you have UDP, there is no handshake. So as soon as you have a route to the endpoint, you can say that you succeed. The multiplex connections are a bit special here because here you may already have a connection set up and you just use a new stream of that connection. So you actually can succeed immediately. And this also has some implications on what happens at the other side, because you may have a reliable TAPS connection, but you actually don't get any connection received event on the other side generated by the establishment. That just happens once you start to send data in this case. Another comment?
Just to clarify, for UDP, one of the open issues we have is to integrate this with things like stun, which actually give you reachability tests. Yeah, we are aware that there are details missing at this point.
So that was the active part of opening a connection. So you also have the listening side. So here the implementation then needs to register the listener object. And depending on what the path and protocol preferences has been specified, you may be listening over multiple paths, you may be listening for multiple protocols. And you could actually get different protocol stacks back as an application depending on what happens underneath in the TAPS system. Data transfer, I think Brian already talked quite a bit about this, that depending on what protocol you have, sending of a message is different. If you have a protocol that has a natural message framing, a message just gets mapped to that. If you have a TCP, then depending on if you have a framer or you will send a sequence of bytes. There is some discussion about how to support all the different send parameters. Again, what that means, what these send parameters means, depends on the underlying protocol you have. In some of them, you may not have support for it, and in others, you can do something useful with them. Zero RTT data is an important case. Brian already talked about that as well. From an implementation standpoint, this is something that you have to integrate with the racing. So you have to have the data provided by the application, and then you have to provide it into each of the candidates when you race it so that you can include it for the protocols where it makes sense. On the receiving side, again, Brian talked quite a bit about that part as well, and it's also dependent on the protocol that you have. So if you have a TCP, you may not have the framing, depending on what has been passed down by the application. And you also have some hints there that the application provides to you so that you know how to deal with the incoming data. If you don't have a notion of a message, then you need to get the amount of data to deliver specified by the application. Termination, the close and the abort functions. The important part there from an implementation standpoint perhaps is that you don't have any half-close connections, so the protocols that support that does not get propagated up to the application. Again, when you have the multi-streaming protocols and you multiplex several TAPS connections onto the same underlying transport connection, you also get some special behavior, because here closing a connection is just closing a stream, and depending on the underlying protocol, you may not then get a finished event on the other side. So you have to be aware that you get a little bit different behaviors depending on what you have underneath in the protocol. Sorry? So there is no functionality for it in the API. You just have a close and abort in the current version of the API as it is right now.
Just a clarifying comment on that, Tommy. I think the point here is that a close in this is being interpreted as a termination of the full connection. We're still discussing half close being able to be sent, but I believe that would be more a property of the sending of a message and saying that now this message is the end of the underlying connection. Please send a fin with it. That's a sending parameter, not a termination parameter.
Yeah, 3 minutes.
Yes, and there are also a number of other issues that are covered in the draft. So some discussion on how to implement the maintenance activities, what you need to do when the protocol properties changes or when the path changes. There is some more discussion on cached state in relation to the system policy. So you may have state cached both by the protocols. So for instance, when you perform Happy Eyeball, you may learn about what protocols work and not, and you may cache information for TFO and things like that. You can also have the performance caches, which is knowledge about your different paths, round trip times, available bandwidths, and so on. And this information may also come from external sources. There is a section in the draft discussing also protocol-specific considerations, so how these actions map to the different protocols and some specifics to think about. And this is the list of the protocols that are currently discussed. As Colin was already commented, we have the rendezvous and environment discovery. This is currently a separate section that needs to be integrated with the rest of the document, and I think there's also quite a bit of information missing there. In general, I think we started from the architecture, so this was the first thing we nailed down to get the agreement there, and then we have the API, and then we started also to have the implementation to see that things match, but there are still, of course, a lot of open issues also in this draft. Okay.
Great. Thank you, Anna. So before people get up to the microphone, I'd like to ask the three speakers to come up here to the front, just so that you're not clogging up the microphone elsewhere. and I see as, well, because there's, hopefully there'll be some dialogue. But I think the most important thing that I want to get out of this discussion is a decision whether or not to adopt these drafts as working group items. So let me start by just taking a hum of the room. Those people who are comfortable making these documents, they're -00 documents, obviously not done, but making them TAPS working group documents today, I'm going to ask whether you are in favor of it, whether you're opposed to it, or whether you need more information. So let's say who's in favor of adopting these documents today? Great. And who's opposed? And who needs more information? All right, you guys can sit down. No, wait. Now we've got about a half an hour we can talk about. Oh, sorry. We're done. And there was celebration in the streets. So now we can have a technical discussion. Yeah, because the questions are going to be for you guys.
We get out of the light.
Oh, yeah, I don't know what I can do about this.
Stand back here. These are all for you two.
All three squeezed with big pots.
That's so cute. Somebody get a picture of that. Kyle Rose. So the section on rendezvous, or the sections on rendezvous. So I feel like there's an intent for rendezvous to be very general.
Paging Dr. Perkins to the pink box.
I feel like there's an intent for rendezvous to be very general, and I think that we're going to want that because it's not just DNS, not even just multicast DNS, but you can imagine service discovery via a database where you have, say, stable names for a service that might move around between IPs or between data centers. So I don't want to belabor the point, but
we know that, and we need help.
Michael Turkson, two comments regarding the send primitive. One is you had some time to live for partial reliability. There are other notions of partial reliability, so make sure you can cover that. And the other one is you had atomic sense. So I agree there is a need to provide in the send call information where a message begins and where a message stops. It could be limiting if you say you do it with atomic sense, which limits you to which limits the size of the messages you can send to the size you can buffer inside your stack.
We have that.
I only had 20 minutes, so I didn't read the whole document. There is a notion of a partial send and a partial receive. So if, for example, if you're receiving something and the transport layer framing or the underlying application layer deframer basically says, I cannot find the end of frame before your maximum buffer size, you'll get back essentially an atomic receive, or no, a partial receive. So it's here's some bytes from this message, and they start at this offset.
And I will provide when it's finished.
Right. Yes.
Okay.
And you can basically use that to put streams, like a stream looks like just one very long message. Right.
Yes. Exactly.
So
And it is the same thing for the send. So one of the discussions that we had early on, and if people have feedback on the naming here, it'd be good. Initially, when we were talking about the data transmission fundamental concept, for a while we had content as the thing, which was essentially the piece of data that you can send at a time, which was related potentially to a larger overall message. We've changed the wording to be more message-centric, but that means on a given send, you may actually send a message multiple times. You send the first part of your message and the next part and the next part, and you can essentially stream that message in. And there are properties of that message which are separate from the fact that I'm sending it in separate chunks, because you definitely need to be able to stream gigabytes and gigabytes of data that you can't all have in memory at once.
Okay, I'm happy. Thank you.
Hi, Colin Perkins. Yeah, I mean, on the rendezvous side, I think the initial goal is that we support the happy eyeballs and things like ICE. And once we have figured that out, which is hard enough in itself, we then make sure and try and generalize it to anything else people care about. Yeah, and as for the rest, if I think it's fairly clear, there are a bunch of That's fine. There are a bunch of terminology issues and perhaps suboptimal names. And if anyone has suggestions for better naming to try and clarify some of this, we are very open to ideas. Naming is hard.
And specifically on the rendezvous stuff, because I believe we have in scope some of the basic parts of that. If, as you're looking at various use cases here, you see things about certain rendezvous models that the current architecture would prohibit or limit in the future, please bring those up sooner, because we want to make sure that it's not a constraint that we have added rather than just something that needs to be expanded upon in the future.
Yes, and just to follow up on that, we are aware that we will need application level help for some of these, and we want to provide the right hooks and the right information to enable that.
Hi, hello. Yeah. Hi, this is Jahed Eriksson, also co-chairing, but maybe co-chair hat off here from the floor. It's about the policy thing. So the architecture draft says it has a system policy. And API draft doesn't say almost anything about the policy. How do you set up the policy? And the implementation draft says we have system policy, we have network policy, and we have application policy. So how do we do, what is the thinking about the architecture draft to include or rename the system policy to something else, or API to include more about how do you install policies?
So there is some inconsistency in the naming between the architecture and the implementation, so that we are aware of.
Yeah, that's great. But I also would like to know the implementation part.
Yeah, as for the API draft is really about, well, the focus of the API draft now is really about the interface that's provided to the application developer. There is missing language about the interface that is provided to an administrator or a user. So that's basically just an oversight, right? So we're basically saying these are the knobs that you have as an app developer. The app developer is generally not going to be setting the system policy, right? It may have its own application policy, but that application policy is essentially represented by the set of, prefer, avoid, require, so on the different parameters, right? So those have to be projected through the system policy. So yeah, we should add something about that and add information about an administrative interface and what that looks like, and it should probably look the same, right? So that you can sort of configure things in the same terms.
But there are also different time scales on these things, right? So, I mean, the part that you say is set in the application preferences can be changing and influenced by what you're sending or what you're in the specific instance. And the dynamic policies are also dynamically learned by the system, and then the default system policies are more long-term, and they can also be updated, but on a different time scale. So basically you have those three inputs
also you have
to work
priorities
with.
and stuff like that between different policies. So tell me.
Regarding the fact that the architecture defines the system policy, actually puts that in the implementation concepts of things that are not necessarily going to be exposed to the API. And the classic example I have of system policy is on a mobile phone, a way to disable cellular data for a given app, or even the carrier pushing down that policy. That is not something that may be ever expressed in any API that anyone could interact with. The part of policy for an application to interact with that, I believe, would be the path selection properties. And so we can maybe specify, hey, you can set your default path selection properties for my process, but there will always be a category of things that are invisible to the app that come from some other part of the system that may be the user interacting with the UI. And I don't think that's in scope for us to specify. We just need to interact with it.
Yeah, I get that on the system policy thing, but I do believe like application need to say sometimes something about the policy that system might need to listen, or the network or the server actually install some policy from a particular app. So I think the only thing I'm asking is like clarification, and how do you do prioritization basically when you have multiple policies active on a packet level or a connection level or a system level. So just a clarification on those things.
Yeah, so I mean, at the moment, we only have specified that you have the constraints you have to follow for all the policy inputs you have, right? So if you can't satisfy them, then you cannot establish a connection. But then, of course, it's in practice more complicated because you may have trade-offs between different things when it's not a strict requirement. And I mean, some of that I think is implementation dependent, and some of it we can maybe specify some more guidelines on.
Yeah, sure. Yeah, just make sure like these things are up in the architecture and the API documents as well.
John Lennox. So a few things. First, responding to that, when you said that those things are invisible to the application, I'm not sure. I think it might be better to say they're read-only to the application.
Yes.
Because so there probably should be a way to find out,
Yep.
hey, I'm not allowed to use LTE, so don't try.
Right.
Yeah, so, which means you still need an API for that. You need a read API for finding out what the default policies are. And then the second thing is I feel like this is maybe a little bit of a quibble, but it is technical discussion. The one event I was thinking I didn't see is something equivalent to like the TCP low water, where I want an event where am I ready to be? Is it okay for me to send now in a way that won't fill my pipe?
Right, and that's a very interesting point, and it definitely was brought up in the discussion. I believe we're trying to actually avoid that because the TCP low water mark is very much a property of how you interact with the socket, right? It's not a property of...
I don't mean that specific behavior, but I mean like I want to keep low latency on this, and I don't want to generate my data until...
Yes, and so I think that's actually the point of that. The callback to sending a message is not when it has been acted. It's actually when it has been essentially consumed by the buffer. And so if I call send with a message and I don't get the callback quickly, I know that essentially there is back pressure, that the TCP send buffer cannot consume this data yet. And so what we've, because we actually have some of these similar models in public APIs already, and we recommend that people, if they want to limit their own buffering, that you should not enqueue another send until you've received that callback. So I think the one thing that we should add probably is a way to tune the size that's willing to be in an outstanding queue within TCP, which will essentially control how quickly those send callbacks will come.
And then the third thing, sort of as a more general point, is just to think one thing that would make me more confident in this API is if basically you're eating your own dog food, which is like, could you implement Quick on top of this in UDP, or could you implement ICE, or could you implement like RMCAT congestion control, things like that? So.
Yes. So I'll say that we have a plan and hopefully funding, and maybe even a person to do an implementation that essentially does Quick and TCP sort of user space versus kernel space racing and all of this as a sort of a proof of concept and referencey implementation for research purposes in Go. So that's.
So you'd implement a user space Quick on top of this API?
We put user space Quick and kernel space TCP underneath this API.
No, what I'm saying is something like, could you use the API to implement Quick?
Yes, you could also do that.
Yeah, because that would be a proof that the API is powerful enough to do things you want to do.
Okay, cool. Well, I'll get another student.
And so from our angle at Apple, we essentially use this internally. For our own prototypes in which we've been doing quick interop, we've been using both inside and then also making sure that the UDP surface of this is what you would need to implement Quick. So we're interested in both aspects of it.
Praveen, Microsoft. So in terms of services, like, applications wanting lower latency or higher throughput, and, there's a wide spectrum of like requirements you could define, both precisely and imprecisely. So in terms of those, is there anything in this API that is planned? Because that's one problem with the sockets API today, is because the application can't really provide intent. It can basically, and we usually end up like compromising and assuming that it wants highest throughput.
Stand up. Yeah.
So what we have right now is the capacity profile, which can specify, in which the application can specify whether it wants to optimize for like low latency or high bandwidth, for example. We also have the concept of intents, that the application can say, okay, this is going to be a big transfer and this is going to be like a small transfer. And the application wants to specify this as accurately as possible, because otherwise the transport system is going to optimize for the wrong thing, right? And so we're trying to figure out which exact properties we are putting in the proposed standard API and which we are leaving up as like a possible extension of that.
So all of that right now is
Teresa Enghart, who also won some of these drafts.
All that stuff right now in the interface document is in Appendix A, I think. So we all of the things that we sort of took in from the 3 proposals and put together that we did not come to consensus on, this belongs in this document, went into the appendix. And that was most of the socket intent stuff and a couple of other things that came from, I'm not sure if they came from Minset or not, but they came from somewhere and are like, this doesn't look actually like it's going to be useful. So
I think those are elements that we have not finalized on the semantics for and the correct way of doing it. We believe that they are useful. So I think if you could take a look at the appendix, open an issue, say like which ones of these we think are the most important, how can we phrase them correctly? Once we get consensus, then we believe we can bring them into all 3 documents.
Sure, great. I think that would be a real value add here, because that's what's missing in the API. The other thing I wanted to say is, yes, the abstraction is great, but from the perspective of the application, if it requests certain services and you pick, your paths and protocols dynamically, the application loses consistency. Like if a repeat connection ends up picking a different protocol, that's may not really help with performance metrics and such. So some sort of consistency guarantee in terms of, hey, if we picked one path, it gets consistently picked, would be useful to specify.
Right. I think when we get into discussions of like a specific deployment, like it's very important to know, what does my server actually support? What are the contracts there? And I think the preferences and allowances do need to take that into account, right? You could imagine saying, I want to prohibit this protocol on this path because I know it's going to have certain problems or will not work, or essentially really bias it towards one or the other. If my server this only gets really interesting when I have a server that starts to deploy both TLS and Quick, and I need to be able to be flexible between them. So as that deployment strategy evolves, I think we're going to try to fine tune the model of setting that.
I think my question is slightly different. So I'm saying that if you went through all the policy and you're racing to figure out what's supported versus not, and you end up with protocol X, the application would prefer that in that session that you continue picking X consistently.
Yeah. So there's
that guarantee is important to make, because if you don't make that guarantee, then your metrics will not.
Right. There's a chunk of the architecture that we didn't talk about at all, which is essentially sort of the security state cache and the transport state cache, right? So the system, any implementation of the system is necessarily going to have to learn about paths, and that's where the stickiness lives. I think we can definitely recommend sort of parameters for that stickiness, but the architecture basically has this idea that there's what we call it an association cache in PostSockets, because association isn't overloaded at all. But the idea is that there's enough information there, and you pretty much have to implement enough information to make this work. You need to have that cache, and then the stickiness is just a knob on that cache. And we should you're right. We should recommend that there's a certain amount of stickiness there in terms of the parameters.
Yeah.
One very, very brief note on that is that in Happy Eyeballs, we essentially already do that, in which we can be sticky to addresses we've already done. And so you can imagine doing the same thing for protocols.
So Gori Fair has just one of the author team, but on the policies and how all that interacts with selection and what we do, there's probably multiple views on what we have as inputs here, because some of these things are actually asking for things from the services which are predictable, and if you ask for this, you will get this in this environment. And other ones are optimization and tuning, and I think we have to kind of discuss how that all fits together. I'm also concerned a little bit that if we do absolutely everything, then we end up with a really, really big spec, and I'm worried whether people will do it. So we're going to have to scope this a little bit.
Tim Jones, from my similar comment to Gori really is to, for example, with the system configuration, where you're pulling all these things from, there's potentially a bottomless pit of things you could use. I mean, one of the things that seems of interest to me from V6 point of view is the provisioning domain work over an int area, particularly when you're multi-homed. But again, it comes back to some of the things others have said. That might be a dynamic thing where the PVD information changes periodically with RAs, and you then have to adapt to that. You may need to re-resolve the addresses, etc. So having some scoping on that and understanding, having an idea of where you think strategically we should be pulling these ideas from would be interesting to hear.
So it sounds to me, maybe Aaron might say the same thing. It sounds to me like there's a collection of other things that people would like to see in these documents about sort of like actually running this system, right? So that might be a fourth doc that we don't have yet. It might go into the implementation doc and then come back out. I don't know. It's not really clear to me where this works, but that does seem to be a hole that we need to consider.
I agree. I think that we won't be able to write that doc until people have built these things.
Yeah.
So I sent this question in email and I didn't get an answer, and I think it might be interesting enough to raise in this group, which is, I don't know, like a year or two ago, there was a woman here who was doing like some very high performance TCP stuff, and she was really concerned about like setting socket options for her TCP and wondering whether TAPS was going to allow her to do that, or were you going to still permit TCP connections that were using sockets and that sort of thing. And I'm wondering, do you have a thought about sort of cohabitating with applications that have more needs for more granularity in the API than what TAPS is going to expose?
So I think part of that is the protocol-specific properties. So that if you pick a particular protocol, you can set additional information on that, but it will only be applied if that is the protocol selected.
So TAPS have to implement that, or is that going to be a straight pass-through? I mean, does the TAPS library maintainer going to have to track all the protocols that are inside it?
No, because that won't work, obviously. So but this is sort of tied to an issue that we kind of just realized that we had when we were looking over this here in London. Is there's sort of a general, right? This is what's specified in the interface document is sort of the low performance version of the interface, right? It's the, we do everything one at a time, right? So batched IO, we probably need to be able to have some sort of way to get out of the way for batch sends. We might need to get out of the way for memory mapped IO and direct NIC access. These are things that we know we need to put cutouts in the API for, so we won't keep people from doing them, but we don't know how to do that yet.
So, okay, so you're answering my question, but you're doing it indirectly, right? In the world where simple things should be easy and complex things should be possible, we focused our attention on the simple things should be easy part. I'm asking, are complex things going to have to go through TAPS, or can they bypass TAPS and go to their transport protocol of choice? And it sounds like you're saying it should all go through TAPS.
Not clear yet.
My gut on this would be that it should all go through TAPS. That is why we have the design principle in there at the very beginning. Like, we need to support specific protocols because we need to address these use cases. We cannot have a worse set of things than this existing standards. From my own perspective, like in our own implementation of this, we're not always going over sockets because sometimes we have ways of doing things more efficiently than a socket option would have. So if all you do is directly expose the socket option through and you allow someone to call set sock opt, you are now essentially exposing the fact that there is a single underlying socket there that does become quite problematic if you are doing something like now I'm doing some multi-streaming thing on top of Quick. There is no FD, there is no any of this underneath that. So the approach that I think we're taking is have a one-to-one mapping of all the existing socket options that we believe are important, and it essentially replaces the socket option directory, and individual implementations will have to manage those.
Sure would be good if the document said that somewhere, because I was looking explicitly for that kind of statement.
We should add that. Yeah.
There's an issue for it. And thank you for giving us some text to put in that issue.
So both for the questions and answers, try to be really precise now. We have 2 more minutes on this.
So yeah, about these properties, we now have a real zoo of protocol selection properties, path selection properties, then specific protocol properties, generic protocol properties, and then they can be specified by the application as required, preferred, or not. And then later, when the connection exists, the application can query which of them were actually satisfied. And so this is, right, as I said, it's a zoo. And I would propose we just make one section in the API draft where we sort these out really neatly, and and then this is also going to be about terminology, because there has been some confusion. And then we have to fix on which ones go in the draft and which ones go in the extension and appendix. We just have to make sure we don't constrain ourselves for the future.
I just wanted to put, Philip Diesel, I just wanted to put it a little bit more into a perspective that I think a TAPS system should have both. It should have some, let's say, more or less auto mode, that as an application you specify it in an as easy as possible way and say, oh, I'm doing the following stuff, please give me an appropriate transport, and allow the implementer of the TAPS system to make smart choices based on various inputs, based on configuration, based also probably on third-party interests. On the other hand, if the application exactly knows I need a TCP socket and I need the following tuning parameters within the TCP protocol, so not the socket options as it was exposed by the BSD API, but as the protocol parameters for TCP are, then the application should be able to do this. But I think these are two different modes, and an application can even mix and match with these modes. So, for example, if it has there's a control connection where it doesn't care, it can use the full auto mode. But then for a specific connection where it exactly knows how to tune TCP, for this connection it can then specify the appropriate parameters. So I think we should support both in the spectrum. And one of the next things for these documents will be how exactly to specify what I'm going to do. And this is exactly what the kind of parameter discussion Teresa was referring to.
Yep, I totally agree. And I think one of the nice things here is that it's really not diverging from what sockets already does. I mean, when I look at socket applications today, there are lots that just call socket connect, send, receive, and there are lots that have tons of socket options. So this is not unprecedented.
Okay, Colin, you're the last one.
I'm the last one. Okay. Hi, Colin Perkins. So we've had, I think, quite a good detailed discussion here. Obviously, this API is being built based on our best guess at what the API should look like and based on our experiences with these protocols, a various set of protocols. I think one of the things that would be useful to get input from the working group is, are there any protocols which don't fit with this API? Is there anything we've forgotten about, any styles or protocols which we've forgotten about?
Well, I was sure I heard somebody say the word multicast earlier today.
Yes, and multicast.
But I think that's explicitly out of scope in the agenda.
Can I object? Yeah. So obviously multicast is one. I was having a conversation with Mark at the back there, and we mentioned ICN protocols. I don't know whether these things should be in scope or not. If there's anything else we've forgotten, and I don't know if now is the right time to have the discussion, but if there are styles of protocols we've forgotten, we should have the conversation about whether they're in.
It's not the right time to have the discussion because we don't have time for the discussion.
Right.
But I think it's a good topic for the list, and I think that taking these documents, my personal opinion is that taking these documents in as working group items should not be affected by that question. Like, there may be additional documents we want to add later. So just a quick show of hands, has there anybody heard anything in the discussion that causes them to change their mind from supporting adopting these documents? Because I heard a very strong consensus at the beginning of the discussion, and I didn't hear anything at the microphone that sounded like an objection. So I'm going to assume that we're going to adopt these as working group documents. We'll take it to the list and just confirm that. And thank you to the authors. I think they're really impressive. It's a real step forward for the working group, and so good job. Thanks.
I have, on this point, in 13 seconds, I have one sort of logistic question. The authors put together a GitHub organization called TAPS API. We can send a link to this to the list for people who to file issues on it. Do we want to bring that under working group control? It's got one repo in it, which is our drafts repo. If they're all adopted,
I don't think we currently have a repo associated with the working group, but I don't really understand the ramifications. So let's talk about
let's talk about it offline. But okay, cool.
Does anybody have an objection to that? Yeah. Okay. Fernando, you're next. Can you get in the queue? Up there he is. Okay, Fernando, I'm getting your slides up.
Good.
Oh, good. We can hear you, which is good because I don't think there's any AV people in the room. So I can't see there. Enter full screen. Okay, we can see you and we can hear you. So go.
Perfect. So I'm Fernando Gont, and I will be presenting our idea on the problem statement regarding IPv6 address usage. As a very small background, this is a document that we had originally targeted at Sixman, and when we presented this document at Sixman, we were suggested that TAPS would probably be a better venue for it. Next slide. So some words about the IPv6 address usage problem statement. Obviously, IPv6 provides increased addressing flexibility. We have like plenty of addresses, and also we have addresses of with different properties like scope, stability, etc. And there are a number of things that are related with the properties of the addresses. First of all, that the implications of these properties are not always well known. Implications in terms of security, privacy, interoperability, etc. And there also exist limitations that are related to the APIs that applications normally use to actually benefit from this increased addressing flexibility. Next slide.
Sorry.
So what this document is about, as I mentioned before, our document was originally targeted at Sixman, so that's why it focuses on IPv6 only so far. One of the first goals of the document is to discuss the implications of differing IPv6 address properties. For example, if you take a look at temporary addresses, what are the implications on security and privacy, but also on interoperability? Because, for example, in some implementations, when these addresses become invalid, if you had a long-lived TCP connection, well, the TCP connection will be teared down. Okay, so these are some of the properties that we want to analyze. Like provide an analysis of all these properties, so that at the time in which you want to make a decision on which address to use, well, you know what the implications are. The second goal is to provide a problem statement regarding IPv6 address usage. This is related with the limitations that we have, the current APIs. And, the third one is to possibly trigger work in this area. Next slide.
We advance a slide.
Yeah, next slide.
Next slide.
What's the title of the slide that you want to have on the screen, Fernando?
APIs, yeah. The last one that I had seen was the one of the goals. So I guess that's I think that's the right one. So some comments when it comes to the limitations of the APIs. For example, when you think about outgoing connections, there's a lot of things that you cannot really specify. For example, you might want for some specific application to have a new address created for your application, whatever that is. You might want to employ different addresses for different users. You might want to have an address be employed just for a single connection and then be thrown away. Essentially, well, there's currently no way to actually select or decide on these things. Next slide.
We both can't do it.
Yeah, and the implications on incoming connections is that typically when you look at the sockets API, the options that an application has is to either bind the wildcard address meaning that you will accept incoming connections on all of the addresses. Or another thing that you might do is to, for example, bind specific addresses. But if you decide to bind specific addresses, well, first, it essentially becomes very non-portable, okay? And also the application will need to understand, you need to be able to, to analyze or identify and know the properties of each of the addresses that you have on your system. So, quite likely what you would expect is, to be able to specify some desired properties on the kind of addresses that you want and, have the API deal with them. But obviously, that's a gap in there because that's something that you currently cannot do. Next slide. So essentially, our question to the working group is, whether this is stuff. This is a document that the working group is interested in, and if that's the case, whether the working group would like to adopt it as a working group item.
Okay, discussion.
So Gori Fairhurst here. Thank you, Fernando, for going through that. I see two things in the document as I read it. I see something about use of IPv6 addresses and the policies and the implications of using these. And I also see the need for a new API if those concerns need us to react. I'm interested in what Sixman actually thought about the security and the use of privacy addresses and the whole framework, because that piece seems very alien to transport to me. But the second part, designing a new API, might be really interesting if the first one was clear. Maybe it should be two documents, perhaps. I don't know. Do you have any feedback on what happened in Sixman and how enthusiastic they were about the whole idea?
Essentially, I presented the idea once or twice, and the response that I think I got was like it didn't really belong to Sixman, and that it would belong elsewhere, like TAPS. If you ask me myself, I think that, for example, the analysis of the properties of addresses, from my perspective, it actually might, fall into, let's say, Sixman or int area. That's my personal thought. And yes, certainly the API is, something that is that more clearly falls within TAPS.
So Ole on the one of the Sixman chairs. So in Sixman, we've defined all these mechanisms for generating V6 addresses of different properties, and you have temporary privacy addresses and different lifetimes and all that. We have specified one document that does on source address selection, which has lots of policy tables and some ways for applications to make preferences for which type of address they'd like. But we're very much a bottoms up. We made this available. We really have no idea how it should be used. So I don't think, this is why we wanted to drop this to the people who could actually make use of these things. We don't want to, the only thing we have is we have addresses with different properties and different lifetimes. And that's kind of where our competency ends.
Mm-hmm.
Tommy Pauly, Apple. Thank you, Fernando, for presenting this. Right, I agree that there do seem to be two separate concerns here. I think the aspect of the privacy and security properties, or when should you use one or the other, feels like it belongs in another document that likely is not in TAPS. I don't know exactly where that belongs. Maybe it's int area. I don't know. However, the mechanism for actually selecting these, I think, really sounds like one of the path selection properties that we've been describing in the architecture, in the API, and in the implementation. So especially, I think, for the case of a server, do I want to be only receiving connections on my one stable public address? Do I want to only receive them on the temporary? Do I want to receive them on all of them? when I'm creating outbound connections based on the properties of these connections, what source address do I want to bias towards? Because those are effectively different paths. When we're thinking of MPTCP, it can essentially treat every source address as a different path that it has. So I think that's really all very relevant. And the right place to specify that would be in the interface that we were just describing. So rather than adopting this draft as a TAPS working group item, because I think it includes other things than this, what would you say about essentially, let's write up a pull request onto the TAPS API that we were just talking about to incorporate that item as one of the path selection properties and describe the correct way for applications to specify the parameters around which local addresses they are willing to select?
Yeah, for me that's fine. The only thing, I agree that there are two parts of this document, but the thing is that the analysis of the address properties is kind of like necessary to be able to do the other part, because obviously at the time in which you want the application to select the some kind of properties, those properties are going to map into specific kinds of addresses with addresses of specific properties. So that's so what I wonder is where we would keep the analysis. I mean, I agree that the API part could belong in a different document, but in some place or another, you should have a discussion on how you map some properties the application is requiring to which addresses, and the logic that maps one thing to the other. Well, is the document essentially, or is something that explains what are the properties of the different kinds of addresses.
Right, and it would be useful to be able to reference that document as guidance. Also, we would need to think, what should the TAP system do by default? Let's say maybe it has a different default for listeners than it does for outbound connections. I don't know, is that V6 ops, is that int area, or what?
I don't think it's us, because we don't have the expertise
Right,
to
we don't have the expertise
know that
here.
it says the right things.
Right. So I don't know.
But I agree with what you said. I think it's good to have it, and good to get it reviewed by people who understand what's said.
Teresa Enghart, I think I see some potential input to the implementations draft there as well, because that's about the default addresses and also the sorting of the potential endpoint addresses, but also local addresses. And I also see a potential relation to the security parameters that we specify in the API draft. So maybe it can also have an influence on those, or vice versa.
So, Gary, first coming back again after having a few moments to think. Is it possible that you can revise the draft just to be clearer on the separation between the things you would see in an API and the problem space? Even if it's just the same document, moving the paragraphs around would really help me figure out who perhaps should look at this. Because I don't really know which group should look at it. I know if you have an API section, yeah, I buy it that this could be the right place, perhaps. But only if the other section already had somebody looking at it.
By the way, when it comes to the API, so far what the document contains is essentially like the problem statement. So it says, well, this is the problem that we have with the API, but so far the document is not proposing any API.
And I don't think you probably need to do that. That wasn't what I was asking. What I was asking was talk about the API implications in a separate bit to the address selection and which addresses you use with applications.
Perfect.
Okay, last comment.
Yeah, Tim Chan. So I think the bulk of this should be included as part of the standard work here, not pulled out as something IPv6 specific. But 6724 does say prefer temporary addresses outbound. So it's a kind of a big clue in there that if your default should be to do that. But whether there are then hints on the path selection to change that, and PVDs might change that, sure. But that's all part of the general architecture, not something that's V6 specific, I would argue.
So I think we have a reviewer. Okay, so that's it for the agenda. Thank you very much to Tom Jones for taking notes in the Etherpad. If anybody said anything at the microphone that is expecting somebody else to do work, you should make sure that the Etherpad captures it, so there is a record of that discussion. It's all available right now. And thanks everybody for coming. Thank you, Fernando. and we'll see you in Montreal. Blue sheets. Has anybody not signed the blue sheets? Okay, follow Zayed. Sign them twice. Early and often. Chicago style.